Okay, so we'll do this first example together, and then you get to try the rest on your own. Okay, so we have data for drive-in movies in the U.S. for a 14-year period. We want to know if it's normally distributed. So first thing we need to do is make a histogram. So you want to go into your list, so stat, edit. We need to put in all those numbers. And I have to make sure I do it right this time. Okay. So go ahead and type all of those in. Okay. So now we're going to go to that second y equals. Make sure our stat plot is on. So go ahead and hit enter for the first one. Make sure it's on. It's on a histogram. And then we're going to hit zoom and then hit number 9. Or you can arrow down to it either way. It's that zoom stat. So we want to sketch this. Oops, sorry. Keep that there. Okay. And we're going to use trace to figure out what the numbers should be on the axes. So if we look there, the minimum is 637, goes up to 926.4, and the height is 11. So I'm going to go up by 2s. So 2, 4, 6, 8, 10, 12, roughly. Okay, so 11. That needs to be right in the middle. Maybe you can draw yours straighter than mine. Okay, then the next one goes up to 1215.8, and the height is just 1. Okay, the next one goes up to 1505.2, same thing, height of 1. Okay, then I have 2 breaks, and the next one has a min of 2084 and a max of 2373.4, and the height there is 1. So it should look something like that, preferably a little straighter. So if we look at that, does it appear to be normally distributed? So you should be saying absolutely not. That is severely skewed. And you want to look at where the extra stuff is. So it is skewed right. So not normal, but skewed right. Okay? Next thing we need, mean and median. So we're going to do our, whoops, oh sorry. We're going to do one-var stats. So stat, calc, one-var stats. Tell it which list you're in. So I'm in L1. So the mean is that first one. It's going to be 970.2. Then we're going to scroll down to get the median. So 853.5. Okay, so do those suggest that the data is normally distributed? Why or why not? We would say no, because they are not close together. So if that data is symmetric or normal, the mean and the median should line up, but they do not here. They're pretty far apart. Okay, so it's looking like we've got something skewed, something that's not normal. Okay, our last step is that Pearson index. So if you remember the formula from the front, or you want to flip back and look at it, it's 3 times the quantity. We need the mean, so 970.2 minus the median, so minus 853.5. divided by the standard deviation. And that we get from our calculator. So go back and just scroll back up on your one-bar stats. It's that S. So it's 376.5 right there. So we're going to do 3 times the quantity, 970.2 minus 853.5. That whole thing divided by 376.5. Okay. So we get about 0.93. So the question is then, does this suggest that the data is normally distributed? Why or why not? So remember we said that if we're in between -1 and 1, we're okay. And this value is between -1 and 1, but it's pretty close to 1. Okay, so that's going to suggest that it is skewed right. So that's what I mean when I say this isn't exactly, it's not an exact science, okay? But having seen the histogram and the mean and the median, I'm pretty confident that this 0.93, that Pearson index, is going to be significant. So it's pretty close to 1, even though it's not over 1. It's not horrifically skewed right. It's pretty significantly skewed right because it is close to 1. So then finally, is the data normally distributed? We would say no, and we would conclude that it is skewed right. Okay? So if you feel like you need to go back and look through those examples again, by all means do. This video will be on Edline for the rest of the semester, so you can go back and look at it whenever you want. But I'm not going to go through the rest of the examples with you. I want you guys to try those on your own. So just you're just going to finish up the examples in your notes. Anything you don't finish will be homework. And the sub, I believe, should be Mr. Patterson. I'm hoping it's Mr. Patterson. Has the answers. So when you finish, you can check them, see if you're doing them right. Okay, so good luck with the rest of them. I miss you. I'll see you soon.